Okay, our next topic is an expression for length of path of contact. So, in the previous class, we discussed all definitions. We discussed path of contact and arc of contact, and you know that path of contact is path traced by point of contact of two teeth from beginning to end of engagement. Now, length of the path of contact is actually given by the common normal to both gears cut off by addendum circles of both gears. If you find the common normal to both gears and check where the addendum circles cut on that normal, so that distance will be the length of the path of contact. That is another definition provided in some texts, but that is not a standard definition, but that is correct. Okay. Now we have to derive it. We have to derive an expression for length of path of contact. So for that purpose, you need a pencil, scale, and a compass with you. Please take it before you start. Okay. Now step 1, you have to draw two arcs as like shown. Okay, two concentric arcs you have to draw. Take an arbitrary point as center and draw two arcs. Second step, again you have to draw two more arcs. They are from opposite side. Okay, like this, such that each arc will cut or overlap the previous drawn arcs. After that, you represent the required points. First, in this figure, C1 is the center of both arcs in the downward direction, and C2 is center of both arcs in the upward direction. Clear? Now there are four arcs, two in downward and two in upward. Arc A1 means addendum circle of gear 1. Addendum circle of gear 1 is represented as arc A1, and addendum circle of gear 2 is represented as A2. And one more point you have to note down: when two gears are in mesh, the larger gear is called wheel and smaller gear is called pinion. That you have to note down. So in our case, gear 1 is wheel. We consider gear 1 as wheel and gear 2 as pinion. Now other two arcs are representing base circles of both gears. Okay, please note down base circles of both gears. Now that term is not familiar. I know base circle. You know dedendum circle and addendum circle. Also pitch circle. So this base circle is actually a definition corresponding to the teeth type. So from where we are starting teeth in a gear, or from where the teeth cut is started, correspondingly that corresponding circle is called base circle. That means from base circle of gear, any gear, for example, from this gear is cut up to what? Up to addendum circle. That is the concept of base circle. Clear? So this one is base circle of wheel, and this one is base circle of pinion or second gear. Clear? Now next one is, first you should know, graphically you should show the length of path of contact. Now you see this figure, you have to add two more lines. You draw tangent to both the base circles of gears. Okay, you have to draw a tangent to both base circles. and that tangent is represented as Mn. Okay, this is a tangent to both base circles, that is represented as Mn. Okay, please note. Then what is point K and L? K is a point where A1 cuts Mn. And what is Mn? Mn is the common normal. And K is a point where A1, what is A1? Addendum circle. So addendum circle of gear 1 cuts at K. And similarly, L is a point where common normal is cut by addendum circle of gear 2, that is A2. Therefore, what we can say, KL will be our length of path. So please note, KL is our length of path. So note down all these things. Mn is the common normal and KL is the length of path of contact. Also note down this angle phi. This is called pressure angle. I'll explain it later, but just note down this. Here, these two angles are phi. These both angles are phi. Next is you have to write all the parameters and its representations. So C1P, we add a point P also. For that I will discuss P. So we drawn base circle and addendum circle. So where will be dedendum circle? That is a question. Dedendum circle will be slightly below the base circle. Please remember, dedendum circle will be slightly below the base circle. Dedendum means that surface below teeth. So there is no teeth below dedendum, but the actual teeth type will start at slightly above, that is called a base circle. That all will later we will discuss. Okay, so just note down one thing, dedendum is there, addendum is there. So probably where will be pitch circle? That's a question. So pitch circle will be between dedendum and addendum circle. Therefore, actually pitch circle will be going through like this. So going through like this, and for the other gear it will be going there. And you know already, pitch circle will meet at a common point, that is the pitch point. That pitch point is represented here. Okay, this point P, that point P is your pitch point. Now you write all definitions. C1P. What is C1P? C1P is the center to pitch point. Center to pitch point will be pitch circle radius. And which one is C1? Wheel. So pitch circle radius of wheel is C1P. Similarly, C2P will be pitch circle radius of pinion. And always remember, I told, larger wheel means larger gear means wheel, and smaller one is pinion. And always for larger wheel we use capital letter, and for smaller one we use small letter. Therefore, pitch radius of wheel is capital R, radius of pinion is small r. Similarly, C1K. You check what is C1K. K is a point on addendum of wheel. Okay, in your diagram you check, K is a point on addendum of gear 1 wheel. Therefore, center of wheel to addendum is what? Center of wheel to addendum will be your addendum circle radius. Therefore, C1K will be addendum circle radius of wheel. Similarly, C2L. Check, L is a point on addendum circle of gear 2, that is A2. So C2 to L will give you addendum circle radius of pinion, that is small ri. So the derivation will start now. First point is you have to consider the triangle C1KN. Okay, check your diagram or this diagram. First you check C1KN. C1KN is a triangle, is a rectangular triangle. Okay, that angles KNC1. Okay, KNC1 is 90 degree. Angle KNC1 is 90 degree because it's a tangent. MN is a tangent, so both cases when we draw from center to M or N, it will be 90 degree only. So it's a right angle triangle. Then check that diagram. C1KN is your triangle now. So from that you have to write an expression for Kn. What is Kn? Just read the equation. Kn square. Kn square will be equal to C1K square minus C1N square, or Kn equal to root of C1K square minus C1N square. And what is C1K? C1K we already defined. C1K is actually the radius of addendum of wheel, that is RA. Then you have to find C1N. Okay, for finding C1N, you consider another triangle, another right angle triangle, that is C1NP. C1NP or C1PN. That is a smaller triangle, consists of that phi. From C1PN, you find cos phi. What is cos phi? Adjacent side by hypotenuse. What is adjacent side? C1N. So C1N by C1P. Therefore C1N will be C1P into cos phi. That is expression for C1N. And what is C1P? C1P is the pitch circle radius of gear 1 or wheel. That is capital R. So what you can write? Kn. Kn equal to root of RA square minus R square cos square phi. Okay. Same thing I wrote. Kn equal to root of RA square minus R square cos square phi. Now we have the length from K to N. But our length required is K to L only. So you get distance from K to P. So read that equation. Kp equal to Kn minus Pn. So if you know Pn, you can find Kp. Now how will you find Pn? To find Pn, again consider the same triangle C1Pn. Same triangle you have to consider, where you found cos phi. The same triangle you find sin phi. Sin phi will be opposite side, Pn divided by C1P, or Pn will be C1P into sin phi, or R into sin phi. Therefore we can write Kp equal to Kn minus Pn, or root of capital RA square minus R square cos square phi minus R sin phi. R sin phi is outside the root. All other terms are in the root. Okay. This is the expression for Kp. Kp means contact from K to P. But our actual contact is from K to L. So similarly you have to find PL. Clear? So how will you find PL? You have to take the other circles and other triangles. That means here you considered C1NK and C1PN. These two triangles you considered. Correct? Now you have to consider the other side. That is this side. This side, what are the same similar triangles? C2M and L. C2ML and C2PM. Right? These are the similar triangles. So if you consider the same triangles on the downside, you will get another expression. Do the same. So you will finally reach in PL. Okay. So similarly, for find PL, you use these two triangles for reference, C2LM and C2PM. So you will get PL as all these capital terms will be replaced by small terms. That is, this is for wheel, all will be replaced by pinion. That is small r a square minus r square cos square phi the whole root minus r sin phi. And therefore the length of path of contact will be the sum of Kp and Pl. That is shown here. So this is our final expression. You put that in a box. Then two more expressions. If you know the length of path of contact, you can find the length of arc of contact. That is by length of path of contact by cos phi. That is another important expression. Put that in a box. And finally, contact ratio is length of arc of contact divided by circular pitch. If you know the arc of contact, you divide it by circular pitch, you will get the contact ratio. And contact ratio is actually the number of teeth in contact. When two gears are in mesh, the number of teeth in contact is called contact ratio. That also you note down. So all these three equations should be put in a box. And remember, what is circular pitch? What was circular pitch? Circular pitch is PC equal to pi d by t. Okay. So this is a derivation for path of contact, arc of contact and contact ratio. So this is all for today. Okay. So understand the definition well. If you have any doubts, you ask in group or personally.